This is one of the expected 1 mark questions from this unit. Okay, here they may ask you closed interval a comma b is dash. In the option they will give you countable, uncountable, measurable, like that they may give you so many options. So what is the answer? If you are not studied it, then you will be confused. You will put countable because it is closed interval, no? So you may think 0,1 will be countable. You may think like that, but that is wrong. Closed interval 0,1 is what? Uncountable. Okay, this is an expected 1 mark questions. That is why I told you. Okay, here you have another one university question. Okay, you can see the statement. The statement is very big. Okay, but proof is also big, but I made it simple. Okay, I made the proof of this theorem very simple. Look at the statement. E is a set of real numbers. Then each of the following four assertions are given, 4 conditions are given, 4 part is there in this statement. You have to prove equivalent. They are equivalent. So here the measurability of E, that is, they are given you E is measurable. If E is measurable, then you are having these conditions. You have to prove what? Equivalent condition. Okay, so let's start proving. Nothing is there in the statement to think more about it. Just what you are doing is you are assuming E is measurable. In the statement they are given you the measurability of E, like that sentence, that words are there. So you are assuming E is measurable and you will prove m star of O difference E less than infinitive. In the first condition, that is what we have to prove. M star of O difference E less than infinity. So you are assuming this, that is E is measurable. You are assuming, and you will prove m star of O difference E less than infinitive. So let's see the proof. Here you are having 2 cases. Is that clear? How many cases you have? 2 cases. The first case is m star of E less than infinitive. That is, outer measure of E is finite. That is what the case 1. Case 2 is outer measure of E is equal to infinitive. Is that clear? So let's see case 1. By the definition of outer measure, you are writing this. You are writing the definition of outer measure here. Okay. By the definition of outer measure, there is a countable collection of open interval this, which covers E for which this. How you are writing this? You are writing this from the definition of outer measure. Memorize these sentences. Okay, it is important. There is a countable collection of open intervals. Okay, there is a countable collection of open intervals this, which covers what? E, for which summation k is equal to 1 to infinitive L of ik, length of ik less than m star of E plus epsilon. Now you are defining something, that is O, script O. Okay, write like this. Okay, script O. Mistakenly it looks like theta, no? This is wrong. You have to follow this to write script O. You define script O is equal to union k equal to 1 to infinitive ik. Here script O is an open set containing E. Okay, this is what you have to write in the define line. Define script O is equal to union k equal to 1 to infinitive ik. Here script O is an open set containing what? E. It's an open set. Okay, containing E means what? Within this open set you are having our E. Is that clear? That is what the meaning of the sentence. Now you are taking measure, outer measure on both sides. Here some of the steps you can't see. Some steps were skipped here. So look at this. Can you see that? I wrote it using pencil. You are taking outer measure to this. So m star of O is equal to m star of this. So now by a proposition you can bring this union to outside so that it becomes summation. Summation k is equal to 1 to infinitive m star of ik. Now that is equal to, you are writing, how you are writing this from this to this? Using a proposition. What is that proposition? By countable subadditivity is that. You will use it in so many places. Okay. Wait a minute. Countable subadditivity of M. That's the name of the proposition. You are using that proposition and you are getting this. Now this can be written like this. Write this as it is, and M star of ik can be written like this. L of ik, because M star of ik is equal to L of ik. This is also you are writing as a proposition. Okay, in the beginning of this unit you will have all these properties. You are using that here. Now this can be written like this now, because here you are having the value of this is this. So that is why less than this. Substituting that. So you will get this. So finally you got what? M star of script 2 less than this. Right? So now in the next step what you are doing is you are bringing this M star of E to this side, so that you will get M star of O minus M star of E less than epsilon. Now by accession property of outer measure, you are having a property. The name of the property is accession property. Using that property you can write this line. M star of O difference E is equal to M star of O minus M star of E. You know the value of M star of O minus M star of E here. So put less than epsilon. So you got M star of O difference E less than epsilon. So this is what they are asking us to prove in the first part. No, you proved it. So in case 1 you have proved. Similarly you have to prove the same in case 2 also. In case 2 what? Outer measure of E is equal to infinitive. So yeah, here is also you are using a definition of outer measure, but it looks different. Okay, so by the definition of outer measure, there is a disjoint union of countable collection of ek. There you got what collection? There you are getting intervals as a collection of open interval, right? Here you are getting collection of measurable sets. That is the difference. There is what kind of measurable sets they are? They are disjoint union of countable collection of measurable sets. That is ek, k equal to 1 to infinitive, each of which has a finite outer measure. It means E1, E2, E3, E4, E infinitive. These are having finite outer measure. How you are writing these 3 lines? You are writing these 3 lines from the definition of outer measure. So by the definition of outer measure, there is a disjoint union of countable collection of measurable sets, each of which has the finite outer measure. Okay. Learn it again and again so that automatically it will store in your mind. Okay. So from case 1 you are writing this. You are having from case 1 you are having this, no? So you are writing M star of, put the suffix k. Like that you have to write, and instead of epsilon, here you are having epsilon, here you put epsilon by 2 power k for our convenience only. Then only you can prove it. So that is why by 2 power k you are putting. No very big reasons are there behind it. This is what the reason. So from case 1 you are writing this, put k in the suffix and write, and here in the denominator of epsilon you write 2 power k. Now here also you are defining something, that is script 2 is equal to union k equal to 1 to infinitive script 2. Here what you have defined, script 2 is equal to union k equal to 1 to infinitive ik. Here you will define the same script 2, but in the right hand side there is a difference, that is union k equal to 1 to infinitive script 2 ok. Here ok is what? Is a open set containing E. This is the same thing you have wrote here also. O is a open set containing E. Ok is also an open set containing E. Now you are taking difference on both sides, this minus E on both sides, so that you will get this. Now in the instead of E you are going to put ek, because E is subset of ek, no? E is subset of ek. So that is why instead of E you are putting ek. When you put E in the place of E, ek, what? Oh my god, you can't see that? Sorry. Is that visible now? Okay, so here listen, from this step to this step, from this step to this step, what difference you are making is, the place of E you are putting ek. The reason is because E is subset of Ek. So that is why you are putting E is subset of Ek. No, so that is why equal to become subset here also. Okay, now this is subset of this. No, this is subset. This is subset. It means what? Within this you will have this. So this is a subset. No, so this will be less than or equal to this. I think that is our next step. We are going to write. Yes. That is, you are taking outer measure also. So m star of this will be less than or equal to this, because this is scripto, the same reasons. Scripto difference is subset. No, that is why when you take outer measure, the value will be less than or equal to this, because this is subset. I hope you can understand that. Less than or equal to, now you are bringing union outside, so that it becomes summation k is equal to 1 to infinitum m star of, bring this m star inside and write the remaining by countable subadditivity of m proposition. So summation k is equal to 1 to infinitum. The place of this you are substituting the value that you have already have. You are substituting this. Let me slow down the process. I am talking continuously now. I feel very difficult to talk. Epsilon by 2 power k less than or equal to epsilon, summation k is equal to 1 to infinitum. You are bringing this epsilon here, so that you will get this 1 by 2 power k. Now epsilon, the value of this is 1. Okay, so that is why 1. So you got this. So in case 2 also you have proved it. Okay, now second one you are going to prove next. You are assuming property number 1, property 1, that is you are assuming this property and you will prove this. Okay, so the second part of the question. Okay, you are going to prove this by assuming this equivalence condition. No, so that is why. So let's see. I made it very, very simple. If you follow my notes, you will feel very easy to learn these theorems. Okay, otherwise you will be stressed. Okay. Choose for each natural number k an open set OK containing a. For you are choosing an open set OK. Okay. Here you are talking about k. This k is a natural number containing this open set OK containing e. It means what? Within this open set OK, you are having this e, for which this condition you are choosing like that. M star of OK difference e less than 1 by k. Now you are defining this. G is equal to intersection k is equal to 1 to infinitum. Okay, so here you are talking about G. No, so you are saying what is that G? G is the G delta set that containing E. G is what? G is a set that containing E. Within this G you are having this E, that kind of another set you are choosing, that is G. G is equal to intersection k is equal to 1 to infinitum. Okay, now for each k you are taking difference on both sides. I think G difference E subset of this difference E. Okay, this will be the subset. This will be the subset of this, because OK is the open set. Okay, this is a very big set. Within this OK you are having E. Okay, within this OK only you are having another set, that is G. Okay, but I will show you. This is OK. Imagine this is OK. Within this OK you are having what? G. Within this you are having what? E. Is that clear? So that is what the concept that is going on within these lines. So G difference is subset of this. So you are taking measure. So when you take the measure, the place of this you will substitute less than 1 by k. So you will get measure of G difference is equal to 0. You are putting 0. How? Here is a question. No. So you proved what they are asked us to prove. So you are putting condition 2 holds, and also what you are doing is that solve. Similarly we can prove 3 and 4. That is how you are ending the proof. Okay, not so difficult. But here is a question, how you are putting 1 by k is equal to 0. That's the question. That is my question. When k equal to 1, less than 1 you will get, I think. Here look at this. I wrote something in the side. When k equal to 1 means, okay, you are putting I think you are imagining k is a natural number. No, already you have wrote it for each natural number. If k is equal to 1 means what will happen? You will get 1, right? Less than 1. So less than 1 means what? The only possibility is 0. Because it cannot be negative. It's a measure. No, measure should not be a negative number. So that is why less than 1. No, so that is why 1 is not possible, because less than 1. So that is why here you are putting equal to 0. Is that clear?